All right, welcome. I am Abby Delaney. I am the marketing manager here at BigRep, and we'd like to welcome you all to BigRep's virtual demo. As I say, I really wish we were in person, but unfortunately, since we can't be, this is kind of our next best thing to bring you these printers live in front of you. And as I did mention, and you'll hear us, we are live. This is not a recording. We're with you live. Chris is in Boston. Till is in Germany. Frank is just outside Boston. I'm in Michigan. And I know you guys are all situated somewhere across Europe, US, wherever you might be. So we're very glad that you were able to join us. As many of us are probably quite familiar with Zoom right now. If not, just a little bit of housekeeping. Depending your view, you can be either in the Brady Bunch view, I like to call it, where you have a whole bunch of little boxes and you can see a whole bunch of names and faces. The best view is to switch over to your speaker view, which is in your upper right-hand corner. That way you can see the demo and the big screen. Just makes it a little bit easier to see what Chris is demoing in a little bit. Also, if you have any questions during the demo, feel free to chat those in the chat box. Those will come directly to me, and then I will chime in and ask Chris or save some for the end to ask Frank and Till as well. So there'll be some Q&A. But basically the agenda will be, I will doing my spiel right now. Frank and Till will have a little bit of a conversation and preview the demo. And then the bulk of what you came for is to actually see the printers. So we will spend the good majority of the time doing that. And so I think that's all from my side. Frank, I will turn it over to you.
Thanks, Abby. Appreciate it. And again, welcome everybody. We wish we could meet you in person, that we could get you to our office in Berlin or at a local trade show. This hopefully will be educational for you. We don't want to talk too long. Some of you may or may not know who is BigRep, so I just wanted to take 1 minute and just give the very high level of BigRep. It's a company founded in 2014 in Berlin with the focus on large format plastic 3D printing. So that was the target, and we are the leaders in large format plastic printer. And hopefully when Chris is done with the demo, you'll see why it's not as easy as others may think to take a small printer and make it large. That's not what we did. We started from the beginning in large format 3D printing. And from the beginning, the company decided it wanted to be a global company. So we have headquarters in Berlin, and Till is running the EMEA region out of that headquarters. But we have a Boston office where some of us are sitting, and we cover Asia through Singapore. And to be a successful company, it takes a lot, and it takes first to have a good machine, but to have the good company behind it, to have all of your filament ready, to have your spare parts ready, to have your service ready, and that's what BigRep wants, to be a full solution. And we're taking that to another level these days, which is to really understand your problems and to be a solution provider. So challenge us on that. We don't want to just sell systems going forward. We want to sell solutions to you, and that means something different to every customer. But enough for me talking. I do want to introduce, again, Mr. Till Hoffman here, our Director of Sales in EMEA, and I'm very excited to have him here to join our webinar. So Till, maybe tell us a little bit about how BigRep meets the industry challenges in EMEA. You're on mute too, Till.
It works, yeah. First of all, thank you for introduction, Frank. Yeah, well, I have to say, I joined around 4 years ago, and in the beginning, we produced BigRep printer for big parts. That means in the past, there was a good solution to get big parts printed for a valuable price. So that was the reason why we decided to develop BigRep and big machines. And so far, I see a lot of branches and applications where you need in time big parts for a good price. Independent from a third-party company which produce your parts. If you have changing prototypes, if you need functional prototypes in mobility, that means also in the existing automotive application fields, also in e-mobility, where the people need to test different molds, different parts, and you have to need parts which you can maybe also use in a real application as soon as possible. This is where parts which are printed on our machines fit in. That means we have Yeah, we have molds. We have also in the production line jigs and fixtures where it makes sense to use a big wrap. We have production tools. Well, there are so many customers we have so far. Yeah, some of them also go up in the sky because they make the drones, which are with people which fly around. So we are in the air, but we also are down on Earth in different big automotive manufacturers.
Yeah, and I think, you know, you're hitting on a lot of things that Big Rep has the experience. We've got customers in all these industries and all these applications, and we've been there. So we've seen the challenges, so we can, you know, meet the challenges of our future customers as well. But Abby usually pokes me by now, so I'm going to have to switch it back to her because we promise our customers here that they came to see a demo, not you and I speak till. So we'll hopefully have time at the end to pull it all together and summarize, but let me go back to Abby for now.
All right, Chris, this is going to be your 30-second warning here. So before we go to Chris there for the demo, just want to do a quick poll here of everyone on the call. So are you currently 3D printing within your organization? Yes, no, but hope to start soon. No, no plans, or you're unsure. This just gives Chris a little bit of background and Frank and Till as well in their conversation. So we know where we're starting with everybody. It's looking good. We've got most people saying yes right now. Some hoping to start soon. Hopefully they mean start soon with a big rep. That's my goal. That's my challenge to Chris. All right, let's give 2 more seconds here. All right, great. Let me just quick share these results. So everybody on here, 71% are already printing. So there's your bar, Chris, to meet. 4 said they hope to start soon. And 2 that we really have to work hard at that have no plans yet. So we're going to work on those guys. But with that, I am going to turn it over to Chris.
All set. Thank you, Frank. Thank you, Abby. Thank you, Till, for the introductions. My name is Christopher Lee. I'm an application engineer and technician for Big Rep. I'm accompanied by our operations manager, Amnon, the man behind the camera. Today, we'll go through 3 of the machines that Big Rep offers. We'll take about 5 minutes afterwards for questions and answers, which Abby will moderate. The machine that I'll go through first is the Big Rep 1. Big Rep was started about 6 years ago. This was our flagship machine. That's been around for those 6 years. Out of the 500 plus that we have sold globally, about 300 of them are the Big Rep 1. We call it the Big Rep 1 due to its build volume of 1 cubic meter in XYZ. The Big Rep 1 offers dual extrusion technology, so retracting heads. What this allows for is multiple materials, multiple colors. You can have support material on one extruder, and I'm going to come a little bit closer. And you can have a different material on the other extruder. So for example, this part here, we had 2 parts that we needed to print overnight. It was about a 16-hour job. Instead of having to replace the filament in the morning, what we're able to do is slice 1 part on one nozzle and then 1 part on the other nozzle. So the machine's able to run them all through, and we just have to remove them in the morning. So a bit more on the extruders. So depending on the speed and resolution that you're looking to achieve, Big Rep does offer nozzle sizes ranging from 0.6 millimeters all the way up to 2.0 millimeters. So like I mentioned, if you want to go much faster, but may not have the best resolution, you can swap on a 2.0 nozzle. If your concern is more aesthetic, then you would put on a 0.6 nozzle. It may take a little bit longer, but because it's printing more and more layers, the part will look a lot better. The gantry itself, a lot of engineering went into that. When you are printing such large parts over such a large Z-plane, you need to make sure that that gantry is perfectly level, the bed's perfectly level all the way up, so you have the same quality from your first layer all the way to the top layer. So obviously we have the 4 large guide shafts and Z spindles, which keep it perfectly level. The motion is controlled by Nanotech stepper motors that are belt driven. So for example, the Z belt, it's a singular Z belt controlled by 1 motor. So anytime motion is moved in the Z, every single spindle moves all at once. So there's no skewing or warping of the gantry over time. The positioning tolerance of the motors are 100 microns in the X and Y and 20 microns in the Z. So again, you're getting very repeatable, very accurate parts over long-term use. These things are meant to run 24/7. I've installed these anywhere from universities to high-end manufacturing facilities, and they all treat it the same. They run it, it's their workhorse, all sorts of materials, running as high capacity as you could imagine. So the bed is 1/4-inch aluminum, and then on top of it is a sheet of polyamide, or we call Kapton film. So it does a couple of different things. First, the Kapton film improves material adhesion, so you're not getting any warping or shifting of parts as you print long builds. Secondly, it does distribute temperature very well across the bed, so you're not getting any cold spots. And then lastly, for part removal, some parts are more difficult to remove than others. If the Kapton is damaged, that is a consumable item, so it's very quick and easy to replace, and we would rather have that get damaged as opposed to the aluminum bed sitting underneath. And now if you want to take a walk behind the machine, we can go into a little bit of the material options that we have on the Big Rep machines. So Big Rep uses 2.85 millimeter filament on spools. Big Rep sells spools anywhere from 2.3 kilograms up to 10 kilograms. Big Rep does offer an open material platform. So Big Rep already has a wide selection of materials anywhere from your TPUs, so flexible materials, to your standard PLA, PETG, and we can also get into the mid-grade engineering materials with some of our other machines. If you don't find exactly what you need, or based on a certain specification, Big Rep trusts the engineering that goes into the machines. We trust them to run third-party materials. We have the first level, second level support with our resellers to bring in new materials, get those process settings idealized as well as we can, and then have that run out on the machine, printing well. So the box you see here, this goes into pre-treatment of materials. So this TPU, this flexible material, it tends to absorb moisture, and depending on your printing conditions and the weather around you, we offer these various accessories to keep your filament dry and a lack of moisture. That way you're not getting any weird bubbling or quality issues as you're printing. So with this one here, it's not actively heated. We do have customers that add in heating elements into the box, but we have other machines that will have that active heating, which I'll get into in a little bit. So a bit on the software that drives the printer. So at its core, the PC panel is Linux-based. We have the HMI, the human machine interface. It's very easy to run through. You have all of your controls, your temperatures, all that stuff. The machine runs off of G-code, so picture CNC control G-code, same exact thing. You can upload your G-code directly to the machine via USB, or if you have this connected via Wi-Fi or Ethernet, you can upload it from a separate computer. Due to safety restrictions, you cannot start it remotely, but you can monitor it with onboard cameras that are sold separately. You can, take screenshots, normal videos, all that stuff. So when you are printing large builds, there are a couple features that we have included to make sure you don't lose out on any of your builds. The most important one is the out-of-filament sensors that are on top of the frame here. There's also a set in the extruders. So if material does run out, a pause sequence is initiated on the machine to where the temperatures are shut off and the machine stops moving, and it will prompt the user to replenish the material and then turn on the temperatures and resume the job. The machine also does have a automatic loss of power resume. So if someone hits an e-stop or power shuts off due to a storm, Upon reboot of the machine, if it does recognize that a job is partially finished, it will prompt the user to resume that. Given that all the temperatures are back up, it will resume it right where it left off, and no harm, no foul, no loss of your 3-day part. That's it for me so far. Abby, any questions so far from the audience?
We do. We have quite a few that have already come in. So first one is around the bed leveling. What requirements are needed for that, and how often does it need to be adjusted?
Sure. So the main hardware feature that goes into bed leveling is our inductive sensor that sits to the left of the extruders. So what this is a fancy proximity sensor. So during installation, the technician or the reseller levels the bed twice. To level the bed, this inductive sensor reads various points around the bed, 8 of them to be exact, and it reads off a value that we have to get each point to within plus or minus 0.02 millimeters. So if you think about that, it's about half the thickness of a human hair. Once every point is within that tolerance, we run an overnight job. Then in the next morning for your installation, we level it one more time, make sure all of those points are even. And then after that, Amnon and I maybe check the bed level once a month, once every 2 months, just as preventative maintenance. But after installation, there really isn't any need to level because we have such tight tolerances, and the way the bed is manufactured, it stays put.
All right, great. How difficult is it to remove from the build plate?
So a little bit depends on your patience. When the bed is heated to upwards of 60 C, 80 C, and based on the size of your part, as it cools back down to room temperature, that thermal process does release most parts. If you have more of a challenging geometry, we also use a 3D printing adhesive called Magigoo. Thankfully, this Magigoo is water-based. So between the thermal process of cooling it to room temperature, and we use a little spray bottle with water to release any of the leftover Magigoo, you wait a little bit and they pop right off. So quite easy.
All right, can you enclose the one?
Yes, you can. So if you're in like a woodworking shop, metal shop, we do have various physical barriers. And then we also have other options if it's more of a security issue where you don't want personnel to freely stick their hands in. We have those options as well.
All right. What's the max weight of a spool of material that the printer can handle?
Big Rep sells upwards of 10 kilogram spools, or 8 kilogram spools, I'm sorry. But because we have a third party option, I've seen spools as large as 25 kilograms on the printer. They may not have fit on the filament holder in the back, but the customers, they had a separate table and they were feeding it directly.
Okay. There's you mentioned 2 nozzles. Is one nozzle for support and one for the main part, or is it possible to incorporate 2 materials into the same print?
Yep, so the example we have here, the orange material is a standard PLA. The black material is our non-toxic ABS. So we have the non-toxic ABS, it was on this guy, and then the PLA was on the other extruder. This extruder printed that entirely, then it moved over back in the y-axis, completed this part, and then finished at the end. So if you wanted to, maybe if we had a more complex part that needed water-soluble supports, then I could choose whichever extruder here, put the support on, and run it that way. Hardware-wise, there is no difference between the 2 extruders, so you can swap them out however you like.
Great. What's the output per minute or hour?
It's a good question. It is material dependent and also geometry dependent. The best way I can answer that is probably go to our 3D Part Lab printing service, to where we can actually get you the full quote that goes into various resolutions and materials, and we'll give you the full rundown of the print times, the material usage, all that stuff.
Okay, great. For large printing without a heated chamber, are you able to control warping?
Yep. So with the Magigoo, it helps. With the heated bed, it helps. And then in our software called Blade, we do have first layer process settings that are a lot different from the remaining layers. We slow down the speeds, we increase the flow rates. We're really focusing on a well-adhered first layer, so you're not getting any warping, like you mentioned.
Looks like we got one more. If anyone else has any questions before we move on, feel free to chat those to me too. Can it do mirror printing?
Mirror, I'm assuming, is tandem printing. So we do have a tandem option. So the main hardware difference is that instead of these two guys directly next to each other, we essentially split the print volume in half, where you would have one extruder on the far left, one extruder on the far right. And so as long as your parts are half the thickness of the bed, we can print these guys in parallel. So whatever is done here is done on the other side there. So you're essentially doubling your throughput.
All right, great. And a good last question, I feel like, before we move on to the Pro, what's the basic maintenance required for the One?
Basic maintenance outside of keeping your guide shafts and Z-spindles well greased and your bed clear, there really isn't much. You know, over time, depending on the material, your nozzles may get a little bit dirty. We have brass brushes and things like that that we clean off. It's more just general upkeep, making sure everything's clean. If your printer gets dirty, you know, they may get gunk in the extruders, gunk in the spindles. As long as you're clean, the machine will do its job and stay running for 6 months, 12 months straight, at least.
How often do you have to clean the nozzles?
So if I'm using a simple material like our non-toxic ABS Club Pro HT, I generally don't. If I'm doing a more flexible material like TPU, you know, if we have a week-long job, I'll check the nozzle after and clean it. It takes under a minute to clean.
Okay. All right, great. We're good for questions on the One. Let's move on to the Pro.
On to the next one. So this is our Big Rep Pro, similar to the One, except a couple key features that I really think this takes it to the next level. So the first being a new type of extrusion technology called MXT. And then we've also paired with high-end CNC controllers through Bosch Rexroth. What that allows for is a lot higher throughput compared to your standard industrial 3D printers. So a little bit on MXT. With your large format FDM, your limiting factor is your thermal process. You know, how quickly can you melt that material and then extrude it through. With the MXT, we have now a pre-melted pool of filament. So now instead of waiting for that thermal process, we always have material to extrude. So now our limiting factor is actually how quickly we can accelerate back and forth in the XY to maintain good quality. And then secondly, with the high-end CNC control system, we have so much data, so much repeatability in our processes where we can now determine what's a good part, what's a bad part, and have the data to back it up. And once we have the data, then we can really idealize settings and maximize our speed, maximize our throughput. So build volume is the same as the Big Rep One, 1 cubic meter. The bed is also the same. It can get heated higher to about 90 C. The reason why it's also fully enclosed is to accommodate for your mid-grade engineering materials. So with the MXT, having it be a new extruder, it does take a little bit longer to bring on materials. So right now we have it running well with nylon and then soon to be ASA with obviously more engineering materials to come. If you do want to run more standard materials like on the One or things like carbon fiber, ABS, we do offer a secondary extruder called ACE. So like the Big Rep One, we do offer the same nozzle sizes on the ACE extruder, anywhere from 0.6 to 2.0. On the MXT, it is a 1.0 at the moment, but in the near future, we'll also include a 0.6 and 2.0. So depending on the material combinations you want, you could have an ACE extruder on one side with the MXT on the other side. You could do 2 MXTs, 2 ACEs, all with various nozzle sizes. So the options are really just up to the customer and the end application and throughput that they're looking for in the printer. So the chamber itself is not actively heated, but because the build plate is so large and it's fully enclosed, the ambient temperature in the build chamber is anywhere from 35 to 40 C. So if you think of ABS, if you printed with it, it does warp a lot. But with the temperatures that we have and the working conditions, we don't see any warping with ABS or really any materials on the printer here. So I'm not swing back behind the machine again. Mentioned this earlier on the BigRep One, pre-treatment and drying of materials is critical, especially for your engineering materials and also your water soluble supports. So obviously we've been printing a lot, no material in right now. We got to reload it and get her going. So actively heated, we have all of the filament out sensors, things like that. Anything you would expect for a high-end piece of machinery. So a little bit of a look under the hood, just to show you the complexity.
Oh, hey, Chris and Amnon, we just lost your video.
Oh, am I getting a call or something? I told you it's live, so
It's live. There we go. You're back.
Yeah, it's
Perfect.
battery started.
Oh, battery, gotcha. So just a little bit of look under the hood to show you the high-end controllers, all the power supplies, all the control systems. So at this point, the One is already 1.1 to 1.2 times the speed of your standard industrial 3D printer. The Pro right now, I think we're really just getting to the start of that with the speeds, and we're already 2 to 3 times as fast or faster than the BigRep One. And I think once you really hone in on the full capability of the control system and also the MXT, we can get upwards of at least 3 to 5 times as fast as anyone. So with something like this, it's more idealized for taking entire manufacturing processes and bringing them over to additive, especially when you get into, as I mentioned before, setting your spec. You print 100 parts, you want at least 95 to 97 of them to be within spec, and then the few that are out of spec, you want to know why they're out of spec and figure out, was it a material issue, pre-treatment, or was it something with the extruders, whatever it is, find that issue and then improve your overall efficiency. So power output requirements. So both the One and the Pro take 208 to 240 volts. And then the Pro uses a 30 amp plug, whereas the One uses a 20 amp plug. So one difference, the Pro is actually Windows-based as opposed to Linux-based on the One. Windows-based, it's a little bit easier, a little bit user-friendly for our software guys in Berlin. What this allows for is if the Pro is on Ethernet or Wi-Fi connection, our software engineers can link up to the printer directly, run all of their software updates behind the scenes. So we're no longer having to wait for technicians to get on site, just us adapting to COVID and the current situations. So also we have the onboard camera that's built in, obviously your remote video feeds. You can check how long the print has been going, how much is left, all that fun stuff. Any questions so far, Abby?
Yeah, we got a few that came in. The filament reservoir that you mentioned for MXT, does it require cleaning?
Nope. So I say reservoir, there really isn't that large of a cavity, just enough so that we're no longer waiting for it. So in terms of cleaning, it's like an FDM, standard FDM extruder where you just prime out the nozzle. It may just take a couple more millimeters of filament, but there's no in-depth cleaning required.
Question, what's the biggest difference between MXT and ACE?
So MXT and ACE, so MXT, obviously the throughput is a lot better on MXT, and then at this time, ACE has a wider range of materials. So I would say that's the main takeaway.
Great. And what are those materials that ACE can print?
ACE is pretty much anything and everything you would have on your standard FDM printer. So POA, PETG, we have POX, which is our second gen POA. We have Pro HT, TPUs, water solubles, everything. And then also your engineering materials like ABS, PETCF, all that good stuff.
Great. Can they be swapped out? And if so, how hard is it?
Yep. So they can get swapped out. You talking about swapping out the extruders or swapping out the material? I
The
can go through both.
extruders. Yeah,
Extruders,
this was
so-
about extruders, yes.
Gotcha. So swapping out extruders, you just got to make sure you heat up your filament, extrude it through, clear it from the nozzle. And then there are 2 thumb screws here with some wiring in the back. It takes maybe 5 minutes, 10 minutes to swap out the hardware. Once the new hardware is on, it takes maybe half an hour, 40 minutes to go through the calibration afterwards. So when you are printing dual extrusion, you need your XY offsets so that you're getting flush parts when running dual extrusion. And then you also need to make sure your flow rate and also your Z offset is good. But all of these calibration tests we'll go through in detail during installation. So we'll never leave the customer, empty-handed or asking more questions afterwards. Obviously we're available for those questions, but the training is always very thorough, and the customers are very dangerous with this printer. So
Okay.
they know what they're doing.
What are the dimensions the Pro can print?
The dimensions, build volume, it's the same as the one cubic meter or 40 inches XYZ.
And the footprint?
Footprint, it's about 6 feet tall by 7 feet wide and 8 feet back. I don't know what that is off the top of my head in meters. I'm sure we can check afterwards.
So you want to convert that? Yeah. How big is it in meters? We'll make sure we have that data converted
we'll get
there.
afterwards.
That's what happens when you're doing it live in Boston. Here's a great question. Structurally, how durable are the parts that can be made by this printer? If I'm a furniture manufacturer and I want to print a chair, can I actually sit on it?
Yeah, Big Up does love their chairs. So I think we have 2 or 3 iterations of this stool here. So this is printed in our non-toxic ABS called Pro HT, about 8% infill. A while back, we tested how much it could actually take. So this is about 1,000 pounds of vertical force before it started to buckle and break. So I think myself, Amnon, Mag, we can all sit on this before it starts to move. So even something like this, it's your not really engineering grade material, so we could get even stronger.
Great. Can you, this is just me talking, but can you walk through the time it takes to print a part on the One versus the Pro and the different extruders?
So I'll stick with the chair here. This chair here takes about 22 hours on the Big Up One. If you're using the MXT extruder, it takes about 10 to 12 hours-ish, depending on the material. And then if you're using the Ace, it's generally about 18 hours. It's about 10 to 15% faster than the power extruders that we have on the One.
Good stuff. Another question here. There you go. What's the main benefit of the Bosch controller?
So with that, you're getting improved repeatability, accuracy, and then a lot more data from your actual movement. So with that, you can figure out XYZ location, you can figure out fan speeds, flow rates, active temperatures, all that stuff. And you can set if my gantry moves a certain percentage away from what's expected, the control system will know, and we can take a look at those reports afterwards and then determine what went wrong, why it went wrong, and then make sure it doesn't happen next time.
Great. Another question here. What's the biggest spool that fits inside the Pro? And what if I need to print
Pro,
bigger?
that would be our 8 kilogram. If you want to print larger on that, it's a good question. We probably just have to have the doors open and then feed it through. But there are 2 chambers, one on the left and then one on the right. So in total, we can have about 32 kilograms of material. So if you want to go larger than that, that's great. But we'll have to swap it out with out of filament sensors and stuff like that. But it's a good question. I know you want to print large, so it's good.
Yeah. Got to get creative there.
Mhm.
I think you've answered this, but just to clarify, the ACE extruder is available today, correct?
Yes.
Okay. All right. Any other questions on the Pro? Looks like we've got them all answered, I think, here. If not, we can try to catch a few more at the end. All right, let's move on to the baby of the family.
All right. So this is the little guy, the baby, as Abby mentioned, the Studio G2. So with the G2, obviously there was a G1 about 3 or 4 years ago. We had a need for some smaller parts. Since then, we've had this build volume now fully enclosed, similar to the Pro. That build volume is 0.5 meter wide by 1 meter long, and then 0.5 meter tall. It still offers a dual extrusion setup similar to the one. It is a single head, but there are 2 independent nozzles inside that print all of the materials like that there are on the Pro. It does not have MXT on the G2, so the throughput would be similar to the BigRep 1. The nozzle size that we have available on the Studio is a 0.6. We do have some customers that bring in 0.4, 0.8, but by default it is a 0.6 nozzle. Like the Pro, because it's fully enclosed, you can do materials anywhere from your standard PLA to your chopped fiber. The nozzles themselves are hardened steel, so you're not getting any degradation over time when you're using the chopped fiber, which some other nozzles may experience. So same setup for the bed. You have your 1/4 inch aluminum and then a sheet of Kapton on top. You have your onboard camera. The gantry is controlled by the Nanotech step motors, so no Bosch for the G2. As I'm going to pan a little bit. And when you are running the engineering grade materials, you need to have your pre-treatment. So on the bottom side of the machine here, we have our heated filament chambers. These chambers can get set anywhere from room temperature upwards of 50 C. So like I said, water solubles, TPUs, we dry them out beforehand, and then we actively dry them at a lower temperature just to make sure that they're printing well and they're not going to have any clogging issues or quality issues. Like the one, we do have the Linux-based application, the HMI, so where we can go through all of our print setups, temperatures, controls, all the good stuff that you need for large format FDM. So one thing I've actually noticed when installing the one versus the G2, I know Till mentioned large parts, jigs, fixtures, things like that. With the G2, I've seen a lot of smaller parts, but just large batch printing. So obviously we're very good at printing large parts, but with this build volume and the way we have our extruder set up to where we can swap out materials midway through the job, a lot of our customers are doing a lot of iterative testing for small parts, and then with each part, they're able to change how they print it. So if they're going to idealize a process setting, instead of setting up 5 separate jobs for smaller pieces, they can have 5 different STLs in their print bed, slice them different ways, different layer heights, different speeds, print them all at once, take them off afterwards, and then determine what process looks best. And obviously, Maggie very soon will go through that process on our software blade, and we'll answer any questions for the slicing area. So I think that's about it for the G2, the One, and the Pro.
Oh no, don't go anywhere. You got lots of questions. Can't go anywhere yet.
All right. I'm here.
What thermoplastics can be printed on the G2?
So same output as the Pro. So that's your standard PLAs to your ASA, ABS, things like that. You're just not getting the same throughput because it doesn't have MXT and also doesn't have the Bosch Rexroth. So materials, they're all the same package.
Great. What are the temperature ranges for the base and the chamber?
Yep. So as I mentioned, 50C for the filament chamber. The bed can get upwards of about 90C. With the ambient temperature, that can get upwards about 35 to 40C. So you're not experiencing any warping on materials like ABS or ASA. And then the nozzles, I believe they're about 280C.
Is there an option to upgrade to bigger nozzles?
Yes. So our nozzles, as they're sent out, you do have the ability to take out the old nozzle, just the volcano nozzle. So because we have an open material platform, there have been various customers that come to Amnon and I that want to run this new material with the new nozzle that they have. We have the capability and the knowledge to swap out the nozzles, run the new material, and get those process settings set up for whatever the customer needs.
What is the print speed of the G2?
Print speed, again, go to the 3-part lab so we can get that quote for you. With it being a 0.6 nozzle, it is a finer resolution. So if I were to compare a 0.6 nozzle print on the G2 versus like a 2.0 or 1.0 millimeter nozzle on the 1, obviously the 1.0 will go a little bit faster because it's doing less layers. This guy can physically go faster because it's extruding less material. So, I mean, I can go in depth with all the accelerations and speeds and things like that, but I would say just go to the 3D-part lab so we can get that conversation going and really get that line by line material usage, print time, layer height, infill, all that stuff.
Great. This one asks about the G2, but is there a filtration system that the G2 has?
Mm-hmm. So on the Pro, there's a setup for a filtration system. There's one on the back of the G2. So we understand that many facilities have a wide range of safety requirements. So instead of Big Rep trying to create a filtration system that works for everyone, we just allow for the hookup of one. So we leave it up to the facilities there to have an external system that they can set up. Obviously, we have experience with other companies doing that. So if they want help from our end or recommendations on what to install based on materials that they're using, we're more than happy to help.
Great. Here's one that haven't been asked in any of these demos. This is a great one. Can the waste plastic be recycled and made into filament and reused?
It's a good question. I'm sure there are companies that do take the leftover material and do that. I don't believe Big Rep does, but I'm sure we can look into that based on the material provider.
Very good. If any more questions? We'll take like one or two more here. One about post-processing. Can you walk through the steps and surface finish and maybe show some examples there?
So I'm not going to come around to the F1 car. We can take a little bit. I'll grab this guy too. So a lot of the materials that Big Rep offers are machinable. They're very easily post-processed. So one example I have here, this was printed in our non-toxic ABS called Pro HT. Afterwards, it was a little bit of sanding just to get the surface smooth. And this is actually nickel plated afterwards. So if you're pushing through, I don't know, an abrasive liquid and you don't want a super heavy material, this is your best option. This one here, 3 separate parts, left, middle, and right, sanded, primed, painted, your most standard form of post-processing. Just show you a little bit of the aesthetic you can get on our printers. So we do have various ebooks and stuff on our website that go through in depth, the nickel plating, copper plating, all sorts of machining and painting afterwards. So I would definitely recommend going onto our website and reading those guys.
All right, great. All right, we are getting close to being the end here. So we're gonna switch over here to Maggie. I'm gonna have Maggie, you get set up here. And while she is getting set up, I am going to do one more quick poll here. So our next poll, what challenges do you guys have right now in the market for additive? Is your challenge with materials, speed, size? I'd love to see everyone say size. That would be my ideal answer right here, but no pressure. Budget, or you're just unsure. All right, they're coming in. Speed so far is leading the pack, but size is up there. Hopefully I didn't, corrupt the data here. We'll give everyone a couple more seconds here. Okay, this is a pretty wide spread. I should stop it because size is winning. All right, I'm gonna pause it here and I will share these results. Size wins, yay! That's great news for us. Next is material, speed, and budget. So I'll have Frank and Till can talk a little bit more about that when we wrap things up here in a little bit. But normally I say live to New York, but Maggie's not in New York today, so I can't say that. But we'll turn it back over to Maggie to talk Blade.
Hello, everyone. So I'm actually in the office with the two gentlemen that you've been watching on video. They're behind me. So yeah, I'm just going to very, very quickly go over Blade, which is BigRep's in-house slicing software. Blade has been developed between our teams of R&D, materials, engineers, basically everyone on the team, to really create a slicer that is made for large format printing, and even more specifically made for large format printing with BigRep machines. So we used to use third-party software, but two of the really important things that came up over the last years were having a really accurate print time estimation and essentially being able to minimize material usage. So those were kind of the two starting points that made us want to create Blade. As you can see here, I'm looking at the BigRep Studio G2 machine. If I go here, you'll see that all of our machines are available with Blade. You don't have to use Blade for all of our machines, which is a question that usually comes up, except for the Pro because of our MXT technology. But because it is a free software and we're developing all of our newest materials with it, we do suggest that you use it if you feel comfortable. As you'll see, I'm just looking at a simple BigRep manifold part that I've brought in. All you need for slicing is a clean STL file. So essentially you import that in by using this little button here. It'll drop it on the bed, which is another great thing about Blade, is that we do have an auto orientation built into Blade. So if your part, if you're not sure how to orient your part, essentially, to have the most precise, amount of material usage, have the fastest print, have the best looking print, Blade will actually do that for you. So I'm in the prepare mode right now. So essentially I could go over here, I could move the part, scale the part, rotate the part, all the basic things in terms of putting this part on the bed. And then up here, you'll actually see our dual extrusion. So we have T0 and T1, and then it actually provides you with all the possible materials that BigRep has to offer. As you know, not every single material works with every extruder or every machine, and you will have an error pop up that won't allow you to slice if it's not compatible, which is also really helpful. As it is, we are open to third-party materials. You are able to customize all your own materials as well within Blade. I'm going to switch over now to the preview mode. Let me just move this a little bit. If I click over here as well, this is essentially, that's another thing that's really great about Blade, is that if you are not super familiar with slicing or 3D printing, there are basic mode and there are expert mode. So it can start from, you just selecting the material size you want. You can select the layer height that you want. If you want to do a visual, which is going to be a bit of a slower print but have a cleaner outcome, or default, which is going to be a bit of a faster print with a bit more of a raw outcome. That's all, you could do simply that and you would have a G-code that you could print. If you are more familiar with slicing and you want to get into a little bit more specific or more experimental 3D printing, this comes with a million different settings. So you can change almost anything to your infill design, to the amount of shells that you want, to your layer height, to printing in vase mode, which is just printing the outside of the part. So there are a lot of different options that you can get into. I won't get into all of these right now as we don't have enough time, but I just want to quickly show you what the preview looks like. If you look over here, this is essentially where it tells you the print estimation, which is extremely accurate with Blade. And then it'll also tell you the amount of material that you're using. And if you do use dual extrusion, if you hover over this eye, it actually breaks down the two different materials that you're using and the amounts that you're using. It also breaks down the time estimation from how long the infill takes to how long the outer wall takes. So it really is just giving you all of the precise ways of making the fastest print that you could do. And then as you see here, it provides you with a really great preview, which is also really important. So you're actually looking at what your part's going to look like on the print bed. And then if you use this slider here, you can kind of go through your entire part to sort of look for any weird hiccups or anything strange, and just get a really great preview of how it's going to look and how it's going to be built up. And then in terms of getting it onto the machine, if you are connected through the internet, you can just actually save directly to your machine and it'll show up on the HMI. But if you are not, if your machine is not connected through Ethernet, then you can actually just save to file onto a USB stick and bring that over to your machine and load it. And obviously, depending on the file, will depend on how long it takes to load onto your machine. But even one of the largest, most complicated meshes that I've loaded onto one of the BigRip One machines takes under a minute. And the last thing that I'll mention about Blade that's really unique, which you're not seeing right now on my screen, but we do also have an automated batch printing. So say you wanted to print this part, fill up the print bed to print the maximum amount if you're doing, printing for end use parts. There is an option, which I can show you, this here, under extensions called batch printing. So essentially you can populate the entire build plate so that each part, they'll all print simultaneously, or you can populate the build plate for sequential, which means it'll print one at a time, but there will be less on the plate to make sure there's no crashing with the gantry of the machine. And I think that's about it from my side, unless there are some questions.
Yeah, just a couple. So first one, does Blade help with part orientation since I'm fairly new to 3D printing?
Yeah, so as I had mentioned, it does an auto orientation, which you can see here also under extensions. So essentially, if you just select this, it's going to orient your part for, optimal printing. Obviously, this doesn't always work. If you have a part and you have a certain surface, essentially that you want to print in a certain way, then you would have to actually go in there and rotate and move that part, depending on that. But a part like this, it's pretty straightforward how it should be printed. But yes, that auto orientation is going to help a lot.
Okay. How does it compare with other softwares like Simplify, and why is it better?
We used to use Simplify as our third-party software, so it's a funny one to bring up. And Simplify is great in a lot of ways, but the two things that I brought up in the beginning were kind of why we had to veer away from that. So essentially, the issue with Simplify is that the print time is not accurate. So that was one of the biggest reasons why we moved over to Blade and sort of developed it alongside with, our engineers, our R&D team, our material team, essentially to get clients a precise print estimation and a precise material usage. And then also, it allows us to then bring in our materials and the settings for our specific materials into the software.
Great. And it's free.
And it's free.
It's free. All right, great. We did have a few other questions, but we will follow up with those just because we're nearing the end of the time here. So I'm going to let Maggie turn her screen off. We're going to do one more poll, and we're going to get back to our wrap up here talking about applications. So we're just going to talk about a few case studies and success stories. But what application are you currently printing? Prototypes, tooling, patterns, end use, other, not printing? Let's hear what you all are doing. And Frank, I'll let you think about this while they're answering this. We did have some questions about Now Lab and support and consultancy. And maybe you can address that once we're done with this question as well. So, all right, you guys are going to be surprised by this, I think. It's coming, one more second. All right, let's share these results. So the most used is end-use parts and actually prototypes. We don't usually see end-use parts this high with our people that are using 3D printing. So I will stop and I will turn it back to you two to kind of take us home here.
Thanks, Abby, and great demo, guys. Really good. So a couple things that stood out. First, I'm really excited about the movement to end-use parts. And generally, we see something like 20% of our business is already an end-use part. So that's quite exciting, but it is the biggest growing and most exciting part of this industry, not only for Big Rep. But Till, let me have you, and the Pro was designed for end-use part, and both from the MXT from an accuracy and a speed standpoint, and the Bosch Rexroth, Chris gave some of those things, but the ability to monitor quality out of the machine and to make sure that you just don't have one, but you can have multiple parts off that can meet a certain quality standard for end use is critical to why we chose such a high-end CNC controller like Bosch Rexroth. But Till, talk for a second about end-use parts in your space.
Indeed, it's crazy what the people are thinking when they see our machines. Their brain is burning, and finally we have customers which make a really end-use part like water drones or water scooter on the one hand. Others are crazy of printing real bike frames, and we received short movies from printed frames where they really take it for riding. It's unbelievable. Others print drones and go up to the sky. It's our machines find really solutions for a lot of different niches, but also for mass products. It's crazy.
Yes, and very exciting. I mean, it's exciting to be in this industry and be in this company because of the change in manufacturing. And of course, it's not going to take over injection molding or milling, but it's going to be standard as we move forward as one other tool. Abby asked the question about the Now Lab, and this is actually a very interesting part of the business. We've had the Now Lab now for years doing special custom work. And now these guys are doing that, but some of the most exciting stuff that we're doing is, I mentioned it earlier, is solutions to solve a problem for the customer that is can be utilized at new companies. And one that we talked about is the scan to part for manufacturing jigs and fixtures. So in a manufacturing engineering environment, it's very difficult for the manufacturing engineer that's on the factory floor to be able to get the CAD data, to be able to make the jigs and fixtures. And Big Rep is working on several solutions, whether it's from an STL file or from a scan part, to be able to make it really easy for those engineers to implement those. And maybe you saw one of our case studies, which is the Airbus box, and the ability to ship really sensitive material around the world without breaking. And those are just two of the final products that the Now Lab team, which is now we call Engineering Solutions team, better fits the name of where they're headed. But Till, let me ask you, I do have one other question I want to address, Abby, but let Till address the Now Lab / Engineering Solutions for a second.
What does Now Labs do? I mean, we have a big brain pool of nice people which go deeper with the customer together in their daily process, and they see how they realize their end parts so far. And together with our brains, we find better solutions to make it faster, more efficient, and in the end, maybe a cheaper way of the final product.
Good, and let's just take maybe one more minute of everybody's time. Again, I think we could chat for a while, but we commit to only 1 hour. And this was the question of budget, Abby, that came up, and I wanted to address that because I always think of budget in many cases as our job of not convincing the customer of the value proposition that we're providing. I mean, one great example is we've replaced a customer competitive system that they gave away to a university and then bought a G2 because that previous large format printer just didn't work. It wasn't reliable, repeatable, didn't get quality parts. And sometimes that, you buy an inferior product, you get zero, just as an example. So I really think that Big Rep is one of the most valuable value-based products, both from what you get for your money and we didn't get time to talk about the German engineering that we have and how that really resonates around the world. Till you take it for granted because you're in Germany, but it really means something around the world. But the value that BigRep brings and the ability to have programs and good solid systems and materials and to package it together with solutions. I will stop there, Till. I'll leave you with the last word, either on budget and then just whatever you want to close out this this demo with.
Well, yeah, I think we are successful because we deliver a good solution for the customers for the valuable price. We do not sell machines, we sell solution, and together with our customers, yeah, we try to make the things always a bit better. And yeah, it's my pleasure to speak to all of you and that you join and that you take time for this session. And we are open-minded anytime for your requests, for your needs, and for emails and calls. And my team and I are looking forward to hear from you.
All right, great. So with that, it's a good wrap up. So just to thank everybody, thanks Frank and Till, thanks Maggie, Chris, and Amnon for that great demo that we had there. Thank all of you for joining, and kind of as a thank you, if you have a part that you want to get analyzed, get an idea of how long it would take to print, the cost of the materials and all that, I will volunteer my team and all of these great people. They can help you out with that and to take a look at your part. So if you've got one that is challenging you, we can definitely help you out with that. So, so with that, I'd just like to thank all of you for joining. Thanks again, and we'll see you soon.
Thanks, everybody.